Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. It's an honor that I can participate in this conference. Thank you, Dr. Muzailin, the General Chair of this conference, for assigning me as the moderator on the last minutes. First of all, let me introduce myself. My name is Fitri Arnia. I'm with the Department of Electrical and Computer Engineering, Universitas Syah Kuala. All right, let's move to our second keynote speaker today. It's my pleasure to introduce you to Professor Koji Nakao. Professor Koji Nakao is a distinguished researcher, Cybersecurity Research Institute, National Institute of Information and Communication Technology, and ICT, and also guest professor, Yokohama National University, Cybersecurity Advisor, and ISC. Koji Nakao received a BE degree in mathematics from Waseda University, and joining KDDI in 1979, Koji has been engaged in research on communication protocol and information security technology for telecommunication in KDDI laboratory. His current interests are IoT security, 5G security, and supply chain security. His present position are distinguished researcher to manage research activities for cybersecurity technologies in ICT, and as a guest professor of Yokohama National University on IoT security research. Koji has also been an advisor for Cabinet Secretariat in the Japanese government since April 2017. So please welcome Professor Nakao. So I think, okay, you have time up to 25 or 30 minutes to deliver your speech, please.
Okay. Thank you. So, I'd like to share. Thank you very much. Okay. Okay. Thank you very much for your very kind introduction. So my name is Koji Nakao. I'm working in many entities, including NICT or Yokohama National University or Japanese government, and to concentrate on the cybersecurity issue. So today, I would like to provide a little bit one specific area, which is the data-driven security analysis for emerging application in IoT and 5G. IoT and 5G are the example, but they can be very useful for you to consider in the area of cybersecurity. So this is NICT. It's NICT building, the Seoul National Research Institute under the ICT environment in Japan. And we are having many research area. So providing the standard time and optical communication, satellite communication, or remote sensing, or the brain ICT, etc., including cybersecurity. So as you may know, if we concentrate this cybersecurity, so there are many idea or research or knowledge should be required, but the data obtained from the network or application is very important. That is to say, data-driven research is one of the core functions for the research of cybersecurity. So data-driven research is to obtain the real-time data collection or real-time data analytics, and results should be practically applicable and shared. And if no data, so it's very hard for us to conduct cybersecurity research. So this is an example of the type of the kind of malware. So as you may know, the malware is a kind of malicious program code, and they have some divided into the several applicable purpose. One is spyware, just inject the malware to pick up the data in the store in your computer. So keylogger is the typing, they're logging the keyboard attached is also categorized as spyware. So second, adware is a kind of connecting to the advertisement supporting software like this. I'm not sure you have already experienced experiences in the adware, but in case of ransomware, as recently ransomware attack is very, very increasing, especially in Japan. There are many incidents occurred because of the ransomware targeted to the healthcare environment. So ransomware is getting a little bit complicated. And this is the one example, the ransomware very old one. But recently the Lockbit or number 2.0 or the WannaCry, so 2017 are very hot topic. So last one, scareware is just like a prompt, this kinds of message, and to obtain the to navigate to make purchase of the new type of scan and analysis. So there are many types of malware, but in our NRCT, try to capture and analyze the initial behavior of malware. As you know, we like to use the darknet. I'm not so sure you have already recognized darknet is. A darknet is unused IP address space. So, for example, in your university, in your organization, you have a registered IP address, but not all your IP addresses are used. Some IP address not used, and we are trying to observe such the unused IP address space to obtain the scan behavior by malware or backscatter or misconfiguration, etc. So this is the just example. For example, in the end there's the malware injected, where malware try to send a ping to the end user. And in the case of darknet, we just observe the scan behavior, but in the real net, response to the malicious or the infected PC and try to connect the TCP connection and send the shell code and hacked and malware. So of course, there are several types of the injection method, but this is example. So this is the scan. I leave it the resolution is not good, but the scan reach NRCT sensor, which is Nictar darknet. So you can see malware located left side and infected to the many PC or smartphone, etc. And malware can start scanning in the first stage. So scan is maybe conducted by using the random the target address basically. So some scan can obtain by using our darknet NRCT. So this is the visualization. So you can take a look on this. This is real-time basis. We have our 300,000 darknet address space in all over the world. And basically most of the IP addresses are located in Japan. But we got a lot of scan from all over the world. This is real-time basis. So maybe it's a little bit surprising to get a lot of scan real-time basis. So which country are basically sending the scan to us? Yes, so we do recognize the red flag country, but also you can see the many Japanese flag. That is to say, Japan are in the personal computer located in Japan. It's infected by malware and sending a scan to us. So this is statistical data, and this is starting from 2012 to 2021. In there, you can see the bar graph. The 2020 and 2021 is very similar. So that's the starting from 2000. We have been logging the recording from 2005, but the data capture data is increasing in last 10 years. So, however, as you may know, there are many scanners located in all over the world, just like a Shodan or sensors or rapidity are the many these are sensor. A sensor has some characteristic. So, for example, the sending the scan to all port or wide area network scan, or the kind of there are many IP address that send 100 to 400 million packets per day. It's a kind of large scanning engine to observe the devices located all over the world. So we try to eliminate such a kind of the scam behavior. So you can see the survey attack, which is scan engine. It's to recognize them red. It's increasing. The attack is the blue one. So this is the top 10 destination port observed by Mixture. So you can see the blue, light blue is the scan targeted to IoT devices. The dark blue is the Linux. So this is the specific scan event observed in 2021. This is an attack targeting to the milk logic observed in that is a router in the Latvian network device. Incorporated dedicated OS in the router. The scan is getting sometimes very high and sometimes getting low. So by using the darknet address or dark address space, we can observe this kind of scan behavior in the real-time basis. And in attack, they targeted this kinds of the milk logic. In this the report of joint research between the Rocker Laboratory, which is a Russian security company, and Yandex. These DDoS attacks have been suspending for about 5 years since 2016. But this is restarted in 2021 because of the botnet called Marriage. So maybe you know, I don't know, you have recognized this kind of. So these kinds of analysis can be very interesting to starting to get this scan by the darknet address space. Another observation of the DDoS or DOS observation by Nectar. So you can see the attacker is located here, and the sending scan to the target server. And sometimes as you know, the DDoS attacker use the source IP spoofing and send the TCP SYN to the target server. In this case, TCP SYN is sending back to our, sometimes not all, but some packet can be sent to our NRCT Nectar. So this is the information. This is a yellow packet is backscatter. So when we receive in 2011, it's a little bit older. This is attack by anonymous. and sending the Sony company, daughter company located in the United States. And the Sony is targeted by our DDoS target by anonymous. This is we can observe the real-time basis. This is the comparison between the this is 2013, and the very interestingly, the United States is the target of DDoS, but not from China. And this is another statistical data in 2017. So in this case, there are many DDoS targeted located in China in this case. So the target is changing. In this case, this is from the September 2020, nearly 2 years ago. Literally very large string act packet of the 40 million packet per hour. It's a kind of the targeted Turkish host. It's the targeted is a Turkish stock exchange or airline sector. So we can observe these kinds of. This is sending the targeted to port 80. This is another example. It's a recent example. Unfortunately, we cannot resolve. This is why these kinds of the behavior can occur. In this case, we did around this is also 2020 in March, but increasing SIM packet from all over the world, including Japan. But the number of packet increasing rapidly. It's 15 million packet per was sent from 1 million source IP address in only 5 minutes. And it's still long, more than 2 days. So this is another example of the response against the DDoS. I hope you recognize what DDoS is. The DDoS is a reflection type of DDoS by using a reflector. For example, this is botnet here, and the botnet send the query to the reflector, but the spoof IP address into the target system. The reflector send back the response to the target. This is the DDoS, and the reflector can be like a NTP or DNS or SSDP, etc. So there are many possibilities to conduct the DDoS attack. So this is very new information. So this year, September, this month, so we had a big DDoS attacks targeted to the Japanese government site or related the company site. So you can see this is the criminal statement. This is the attack declaration. So name of the attacker is Killnet, is sending DDoS packet from using the many infected devices or system located all over the world. Very, very large number of the devices are used, more than 300 million, sorry. So in this case, this is the statistical data, so which obtained our honeypot. This is not our nectar, but in that case, we observe this kind of DDoS packet by using honeypot. I can explain the honeypot later. But example, this URL is this is the target URL, and this is IP address. The time is September 6th, starting just 1 minute first, and then nearly 1 hour. This is a reflector is in this case DNS. So in this case, Japanese the website or the government site are somehow difficult to access during the attacking by this using the DDoS. So in our case, we try to implement honeypot under the reflected. So this is called DDoS honeypot to obtain the real query attack, which is DDoS attack, by using the honeypot. And that is to say, as you know, this kinds of attack, if it is a very big attack, the first attack is very small attack, but the increasing in the rapidly increasing within or 2 days or less than 1 day, etc. So we can observe this kind of DDoS attack by using the honeypot and send alert to the several organizations, including ISP. So we can send the start DDoS attack by email, and then end of DDoS attack by also email. So this kinds of information can be shared or transferred by using the ICT ISAC located in Japan to the network operator of ISP. And ISP have some collaboration with the end user, which is the target entity, and to respond and reply to the DDoS attack. So this is one example how to utilize the honeypot. But in the case of IoT devices, what I explained previously, response against the attack from the IoT devices. IoT is many application use, home network or the medical, healthcare, IoT, ITS, vehicle communication, car communication, etc. So this is an example. This is a catch of the many applications in the discussing the standardization. But typically, so this IoT utilization have some strong connection with how to use the application in 5G application. This is the example. And mobile communication or mission critical service or massive IoT use in a home network, IoT, or smart city, smart grid, etc. So this is another example. In the case of IP camera, this is one of the IoT. So Insecom is located in Russia. It's disclosing the image of IP camera. This is the first page of the Insecom, and try to click the country, but Japan is number 3. So this is the example of the display image or the image of the captured by IoT IP camera. Sorry. So moving to the IoT threat, there are many articles obtaining the IoT threat. This is also example. This is concentrating on only IoT. This is also real-time basis, but the only limited their target is using the IoT port. So port 23, etc. So what is a root cause? This seems to be a telnet, which is port 23. So in our system, we as I said before, we launched the honeypot, IoT honeypot, and the honeypot is looks like this. This is a honeypot configuration. We can also implement the sensor located in the other country, and we have more than currently 13, more than maybe 19 countries at the latest, and they observe the sensor, and the data of sensor can be corrected in Japanese or the front and the proxy, and analyze such a kind of behavior in the Japanese environment. So by using the honeypot, we got a lot of our devices and the types of model observed. And in 2016, so this is a Mirai outbreak. This is IoT malware. So IoT malware Mirai, the name is Mirai, is in future in Japanese. More than 500,000 IoT devices were infected by Mirai. And specifically, the destination IP address equal TCP/SNIPER. It is a very simple characteristic. So Mirai has the source code is uploaded to the Hacker Forum and GitHub. So therefore, the Mirai pandemic is very, very getting larger. This is a pandemic, the Pandora box opened by Mirai. So that is to say, using this kinds of IoT malware, it's make a very big impact to the many society, many applications. So many attackers can learn how to implement the IoT malware by using the Mirai. This is an example trend of attacking the Mirai. So in this case, there are many the country are located in Mirai. In this case, there are many attack Mirai is located in China or India, etc. That's blue one is others. So this is a recent trend. Number one, diversification. So this is in Japan. During the global Mirai outbreak, the number of domestic infection is about 100 per day. And situation of fire opposite share in Japan, that is the Japan what didn't care about this. But after 2017, the port number is more diverse. And service other than a telnet are targeted one after another. IoT devices which are not infected are getting infected. So this is the same slide what I explained by Nectar. The top 10 destination port observed by Nectar is about 32% of top 30 part. It's attacking to IoT devices, and attack targeted to Linux service also increasing by using this statistical data. So in this case, this is an example. This is an example of the rapid increase in infection with domestic IoT devices. This is SSH attack, and infection were via SSH, not telnet. This is another example. And this is also inclusion attack using IoT. This is also in Japan. This mass infection domestic router. This is exploitation vulnerability discovered in 2014 instead of telnet. And that is said, it was an attack exploited by vulnerability in the SDK for the microcontroller chips. So that is to say, what I want to say is the kind of attack by using the IoT malware is getting diverse, and so many vulnerability are getting used. So this is the summary. The port 23 or 2323 are used in Mirai, but in this case, there are many the port number used. Next one, attack sophistication. So this is one of the trial in the cleaning the IoT devices, IoT malware. So we purchased devices known to be compromised widely, like IP camera, router, or printer, etc. And record the normal status and process, and also intentionally infect the IoT malware. And of course, check the C2 communication. And fourth, we did a power off or reboot by command or factory reset, and compare the status before and after. And all malware were removed by operations such as restarting the main power supply on the devices. That's fine. But recently, the persistent infection type of malware, this is VPN filter was arrived. That is reported that 500,000 devices have been infected worldwide in the case of VPN filter, because this is the persistent infection characteristic, and the infection is prolonged. There is a fear of various activities such as information gathering, not only DDoS attack, but also sabotage. So this is the kind of the analysis by using our honeypot. So not the VPN header, but the another IoT devices malware, so-called Hajime. This IoT malware is a new type with persistent infection. So you can download the malware using the legitimate device functionality, download the hidden file, and startup scripts are the using, and start program copied at the time of infection. So malware is a persistent infection malware and created exclusively for the device after understanding the unique characteristic of these devices. This beyond the Kelvin, so you can see over 50 vulnerabilities are exploited by IoT malware since Mirai. So this is another example in the case of IoT honeypot. We're using honeypot. So this is the newly provided not only simple IoT honeypot, but this is export. So honeypot is try to utilize the real devices like router or IP camera or etc. A printer in this case. So I try to analyze and try to observe the real behavior using these kinds of little extended type of honeypot. So using these kinds of the export, so extended honeypot, we can observe the IoT ransom. For example, the IoT devices NAS, a network attached the storage, has been targeted by ransom attack in Japan and worldwide. So in this case, maybe time is limited, so I'd like to speak. This is exploited file and ransom node. So this, in this case, the latter file is, this is encrypted all file and leave ransom node in every holder so that it can be easily found by the victims user. This is our example ransom node. All your data has been locked, and this is encrypted. How to unlock, decrypt the instruction located in TOL with the user Tor, a browser for access online onion website. This kinds of ransom node is left in the many folders. This is the national security measure that the related IoT threat. This is the kind of notice, which is just national project. Notice is try to find the vulnerable IoT devices by using the often use the ID and password in the IoT attack. So in this case, this NICT is trying to make an ID and password to obtain the vulnerable IoT devices, and capture such IoT devices can make a lot to the end user. So the password should be more strengthened, etc. Another solution is the Nectar. So obtain the infected IoT devices by using Nectar. So basically Mirai in this case. And this is the combination of active control by Notice and passive control by Nectar. So this is an example of the result of the July 2022. This is the latest one. And in this project, 72 IP ISPs have participated in this project. And there is recent statistical data. The 4,506 is a lot was sending by using the Notice project in July. In 2022, 250 daily average the alert by the Nectar in July. So these results can be very useful to improve the IoT security or improve the IoT solution, etc. Another example, this is a very, very specific national security IoT threat research. This is research. The name is Mitigate. So I'm reading this project. So Mitigate project is focusing IoT malware and how to observe IoT malware behavior and how to remove or how to make it non-functionalized. That's the kind of the many very deep research. So sophisticated honeypot analysis of participants' infection IoT devices try to use the IT technology to detect the IoT malware detection analysis or to obtain the behavior, or how to provide a remote disabling IoT malware, or how to provide the remotely disabling IoT devices, etc. This is the how to organize this kinds of the activity in the Mitigate. So it's a complicated, so I need more time to, so I try to skip, but you can share this slide maybe later. In the national security measures against 5G threat. So 5G is getting so operated nowadays. But in Japan, the 5G are often used, but the not so real 5G applications have not yet implemented correctly. So 5G is a very common network platform by dynamic and sensing the secure network slice. As you know, the 5G has a very specific characteristic. In the case of data speed, it's getting very big high speed or very low latency, so-called zero latency, and connection, which is called a massive connection. There are three types of very interesting characteristics in 5G. But as you know, the 5G utilizes the virtualized platform, and over the platform, there are SDN or NNV implemented, and splicing capability also implemented to identify the sector-specific 5G application. And this is 5G is based on the cloud computing, and core network will make the mobile edge computing is connecting the cloud computing. So this is the same. There are many applications, but this is an introduction of what are the 5G security guidelines discussed under the Japanese project. So we are providing the threat analysis and the in the 5G platform. So we implemented 5G system test bed, so-called test bed, and provide the kind of the test scenario to obtain the threat under the 5G environment. So we use the 5G laboratory network using the different 5G implementation method and using the NFV infrastructure, OpenStack, etc. The testing scenarios, just like a fuzzing testing or DDoS attack, it's a kind of scenario, or security control test and the penetration test, etc. So this is an entire 5G system test-based configuration. So we did implement the core 5G basically using the open source data tool and around radio access network, MEC, and virtualizing infrastructure. And this is the one of the result of the our security guideline, which contain the threat, providing threat model and common security threat and threat to NFV or threat to the another component, radio access network, core network, etc. Threat to make. And based on the threat, so we obtained also a control, which control stands for security measure. So organizational control, people control, operational control, and physical control, technical control. So which may, in the case of technical control, contains the virtualization control, radio access network control, core network security control, etc., MET control. So in our case, we summarize this kind of control and threat. So we propose this kind of guideline to ITUT, which is our international standard telecommunication standards organization. and to make the result as one of the recommendations for international standard for our reference. And 5G environment and has a strong connection with connected car in 5G. This is the many utilization of 5G are expected. It's very different, many connection in the automotive environment. This is a landscape. And as you know, there are the vehicle located at the bottom, but not going to the core cloud, core 5G. But it's often the case the data can be shared and exchanged through the roadside unit, which is allocated to MEC in the 5G. So this is one of the interesting characteristics in the vehicle communication. This is an example in China how to utilize the 5G in the city plane. And there are many the connected car ecosystem, so we can summarize these kinds of including attack surfaces in the vehicle. So in the kind of the threat and the potential, also many threats are recognized, back-end system threat car coming from the communication channel or the updater procedure, etc., human behavior. So many threats should be recognized and based on the research on the connected car under the 5G. So this is one of the very interesting research activity. So this is the last the portion of my slide, and the cybersecurity research in NICT, which is my organization. In NICT, there are many the research activity. You can see the global monitoring and local monitoring is the horizontal, and vertical plus and passive monitoring and active monitoring. So we have many projects located here: Nectar, Daedalus, the DLDOSET, honeypot, IoT honeypots, etc. So you can see in the middle, Cure is a kind of data set, but using the AI and 5Gs are also focused, and using AI, Cure is very useful. Cure is a kind of the big data repository obtained in NICT. There are many categories: darknet data, livenet data, malware-related data, spam data, Android data, blog and article, OSIM data, and the web-related data, honeypot data, threat intelligence, etc. So these data can be shared and utilized for the correlation analysis based on the AI technology. And we launched the new project on Nexus, cybersecurity, Synex is a kind of name of project. It started in 2 years ago. And this is the kind of big issue. It was before I launched the new project Synex. So we are facing this kinds of problem. So low self-sufficient rate in the cybersecurity products in Japan, and negative spiral, the cybersecurity data shortage. So this is one of the purpose of my presentation. If there is no data, so no R&D occurs, no products can be improved, developed, and no data. So that's a kind of negative spiral. So therefore, Japan needs now is to get a large-scale collection and accumulation of real data, like honeypot or Nectar, darknet, or steady and static analysis of the real data. So real-time analysis should be very important. And evaluation of domestic products. So using the test bed under the university environment, we are trying to evaluate the domestic products based on the statistical analysis and the static analysis. And generation share and Japan made a threat intelligence. That is the purpose and our hope. And this is just the explanation the current ongoing collection and accumulation study and statistical analysis, and the evaluation of domestic products and Japan-made threat intelligence. This is ongoing, and we have some kinds of a sub group, co-nexus, or we call it co-nexus. So somehow the SciNex project is somehow a constructive way to develop the by using several sub-projects. So SciNex also not only providing the cybersecurity or the research activity, but also the kind of national security training center. So awareness, improve awareness, and such a kinds of cybersecurity and the national training center are buying. So this is the summary of my talk today. Within our diversification, sophistication of attack and expansion of the targets. So we recognize that there's some difficulty to grasp the overall picture of the attack. But it is also very important to understand the intent or background information of attack. So effectiveness of the data event or data-driven analysis for their efficient observation and utilization of AI, etc. So as you can recognize through my presentation, so using the darknet or honeypot, etc., we can observe many data. So maybe not only such a kind of data, but also using the OSINT data or the LiveNet data, we can analyze somehow very efficiently. And AI may be very useful for that purpose. So today we don't have enough time, so we cannot provide the AI technology how to utilize cybersecurity, but we are doing such a kinds of activity. So important not only to analyze the current situation, but also to predict attacks that will occur in the future. That is to say, in the first portion, we try to observe the current behavior, but based on the analysis, we need to obtain the kind of analysis for such the kind of prediction. So using the symptom of attack or small attack in the first stage of the attack. So SciNex can be the basis, core data can be utilized. And flexible security measures control and system can respond to the change in the attack, such diversification or sophistication are very important. So need to apply to IoT 5G solution in the case of smart city, etc. So last in the conclusion, effective implementation under the context of research collaboration. So sharing the observation data. So that is to say, the NYCT has many data obtained from the network or darknet, honeypot, etc. So we are very much hoping to share this kind of data with any researcher located all over the world. And if we can share the data and share the joint share and analysis the data, and the results can be shared. And of course, such a kinds of the analysis are the data shared, and we can obtain the kind of the joint research, so producing the joint paper, etc. Such a kinds of the approach are taken by the data-driven approach of cybersecurity can be very effectively and conducted in not only Japan, but also with other countries. So I'm sorry, it takes a little longer, but thank you very much for sharing my presentation. And if you have any questions, I'm very happy to answer. Thank you.
Thank you very much, Professor Nakao, for an informative and very comprehensive speech about data-driven security analysis for emerging application in IoT and 5G. Now I'm welcoming to one or two questions from the audience. We already have one question from the Zoom platform. Oh, do we have any question from the audience here? So I'll pick two questions, I think. The first is from the Zoom, and the one will be you. The second one, I'll read the question from the Zoom platform. The question is, as we all know that the IoT already implemented in most of every field in our life, especially our own home, like surveillance camera, automatic light, bulb, etc. There is a rumor that you being watched and controlled by the internet. Is there any guarantee that our privacy is still secure in ethical terms? Is there any possibility in the future, maybe we all don't have our privacy anymore? Is there any solution for this? That's the question, Prof. Nakao, please.
Okay, thank you. Thank you very much. So in this case, in our approach is we are trying to use the passive monitoring. That is to say, the malware is injected one of the IoT devices located somewhere else. We don't know what kind of IoT devices used. Of course, we can analyze the IoT devices, but we just received the scan behavior, or we can use the same malware by using the honeypot. So there is no any violation of the personal data. So we can get the scan data. Scan is coming from IoT devices. So we are not requesting anything. So utilizing such a kind of data, so we can kindly make an alert. So your IoT devices may be infected by IoT malware. Malware can have these characteristics, etc. So of course, if we are trying to find or to active scan and to obtain the data from the IoT devices, which may not be infected, that's its problem. That's the problem. So we don't touch such a kind of area. So, but in general, there are basically two major approaches. In previous days, we are the cybersecurity technology is trying to focus on passive monitoring. So that's we receive the data or receive the scan data, etc. But nowadays, we try to make a little bit active passive monitoring. Active monitoring. So in that case, so we need to resolve such a kind of privacy issue. So at this point in time, so based on my presentation, there's no issue regarding the privacy. But in the future, as you pointed out, so we need to resolve. And after resolve such a kind of privacy issue, we can continue to make the research. Is it sufficient for you to answer from my side?
Thank you so much, Prof. Nakao. I think that's the answer from Professor Nakao. I'm welcoming the second question. Please come to the stage.
Thanks a lot, Prof. Koji Nakao, for your presentation. It's very interesting to us, of course. Before I'm asking, let me introduce myself. My name is Rudy. I'm from Informatics Syekh Kuala University. My question is how to deal with laptops that have been affected by ransomware, such as WannaCry. Is there a way to unlock the encryption without having to pay the ransom? Thank you, Professor.
Thank you. Very interesting question. Because lack of time, so I have not providing the latest threat information regarding ransomware. So in the case of ransomware, it's a kind of targeted attack, or sometimes a little bit random attack to the end user. But ransomware is a bit difficult for us to observe. But in the case of honeypot, so we can observe the IoT ransom. But the ransom, once encrypted to the files or data located in your PC, it's very hard to resolve. But there are many discussions how to conduct the solution against the ransomware. Ransomware is getting very, very sophisticated recently, but the data should be backup correctly, and backup solution is not both way direction, backup to single direction. And that is to say, if the end system has correct and efficient backup solution, the ransomware may be resolved. Or backup using the backup data, data can be utilized to recover. But most of the cases in the targeted end user, it's not so easy to resolve. After paying the ransom money, so through the Bitcoin, but there's no guarantee to get the key, decryption key. So recently, it's not only encrypting data, but also the disclosing the data to the public. So ransom attack is getting a little bit dangerous, but they should be correctly to prepare the backup solution or antivirus software or kind of using the signature. So the ransom malware should be analyzed very promptly and to share the data with the many cyber security vendor and end user, and to provide the backup solution before such a kinds of the attack. That's kind of my understanding. If I can provide the more information regarding the ransomware, and if you can, I can send you if possible. If you give me your email address. Thank you.
Okay, you can give Prof. Nakao your email address if you need some more information about the data ransom. Okay, I think because of the time limitation, I think we cannot go on. Although your speech is very informative and very comprehensive. Thank you, Professor Nakao. But before ending this session, I'm inviting our General Chairman, Dr. Muzailin, who will deliver the token of appreciation on behalf of the iCeltics 2022 committee.
Dear Prof. Koji, we really appreciate the time you took for our conference. I'm really grateful for your speech and also for the thoughts and experiences you share with us. Allow me to give highly appreciated through this certificate. Again, thank you very much for your cooperation and contribution.